In this lecture, we are going to talk about the multiplication, division, and the power of, well, terms. Okay, although here you see what you see is the multiplication, division, and powers of powers, but actually they will become terms, which are, in the multiplication of sign, number, then variables, right? Okay, so the exponent properties are how we multiply, divide, and do negative power on powers. So when we multiply two powers with the same base, okay, you need the same base. The number down there is the base. So when you multiply two powers with the same base, you keep that same base and add the exponents. When you divide two powers with the same base, you keep the base and you subtract the exponent. Then anything to the zeroth power is 1. We already have positive powers, right? 2 to the third power, say 2 to the third power is this many times of this number repeated under multiplication. So it's 2 times 2 times 2. But when the exponent is 0, you can't take 0, 2 and multiply. So we make the rule 0 power, it's always 1 for any basis, as long as the base is not 0. So a is not 0 here, okay. And finally, if you have a negative exponent, we define the negative exponent to be the reciprocal of the positive exponent. Okay, so when you have a negative, same thing, you can't say, I take negative 3 2's and multiply them, right? So what you do is, you take 3 2's and multiply them, and at the end you put that result on the denominator. Okay, so these are the basic rules of our exponents, but in practice they will be our x's. Now, an expression with negative exponent is not in the simplest form, which means you cannot leave your final answer with a negative exponent. All the negative exponent has to be converted into positive exponent with the definition, rewrite it as its reciprocal with positive exponent. Now let's see what kind of questions we are going to do. So first we are going to multiply and divide terms. Again, sign, number, variable. So when you do them, you multiply two terms by really multiplying the sign by sign, number by number, then variable by variable. For example, our first question, I'm having 3x squared times negative 5x. So sign gives you the sign, number gives you the number, and the variable gives you the variable. What I mean is 3 is positive 3, right? So do positive times negative, and the multiplication that gives you negative. So here you have negative. Then you do 3 times 5, which gives you 15. You have 15. Then you have x squared times x, which is x squared times x to the first power. You are multiplying two powers with the same base x. You keep the base and you add the exponents. That's why I'm adding that invisible 1 back, because I'm adding 2 with 1 to get the 3. Oops. So x to the third power. As you can see, multiply two terms is one-step thing. But in this step, you actually are going back and forth 3 times, following the order. What is the result? What is the sign of my result? What is the coefficient, the absolute value part of the result? And finally, what is the variable of the result? Similarly, you are going to do the same with division. Two terms, 15x third divided by negative 3x. So you are going to do positive divided by negative. This gives me negative. So it starts with a negative. Then 15 divided by 3, that gives me 5. Then x third divided by x will be x third divided by x to the first power again. So this is x 3 minus 1, which is 2x squared. Now finally, the third question x to the fifth power, I just want to, use the definition of negative exponent directly. When you have a negative exponent here, then you see that this negative sign, what you do is you are going to just forget about it. Okay, that would be x to the fifth. You make the exponent positive, then you put the whole power on a denominator. Take a reciprocal. So you drop that negative sign and flip the power. You will have 1 over x to the fifth power. More examples. 3x to the negative 5. Well, again, this is about the exponent negative 5 is only on one symbol in front of it. So what you have is 3 times the x to negative 5 power. Okay, it's not 3x together to negative 5 power. If 3 is part of the power, it will look like this way, not what we have. So you are really having 3 times the active x to negative 5 that we already found, right? So that's 3 times 1 over x to the fifth power. And how can you do that? It's a multiplication between a whole number and a fraction. You need to put a 1 under the 3 to make it fraction with fraction, then you multiply across. 3 times 1, the top gives you 3, and bottom 1 times x to the fifth is x to the fifth. It's 1 times the invisible 1 coefficient if you want. So 1 times 1 gives you 1, as coefficient 1 will be omitted, so we don't write it. And finally, the answer will be 3 over x to the fifth power. And again, here I try to make you again remember that the question is different from 3x together under parentheses under the power. Okay, that's not what you have here. So 3 is not part of the power. Finally, question 5, I'm having 3 powers attached together, which means they're all multiplied to each other. And when you have all these multiplications, remember the powers, when you multiply powers with the same base, you can keep the base at the exponent. So you are going to take the powers of x's together. That gives you x2 plus negative 4, right? You are adding those two exponents, and you keep the sign of the higher number and you subtract. It would be x negative 2. Then y is by itself, so you bring that down, y negative 3. Then we are going to write each of these two negative powers to positive. I drop this negative sign, okay, this negative sign, I drop it, x squared, and I put it on a denominator. Similarly, I drop the negative sign in my negative 3, it will be y to positive 3. Again, flip the whole thing. I'm having a multiplication between two fractions, 1 over x squared and 1 over y to the third power. I multiply across. 1 times 1 gives me 1, and x squared times y third. Well, there are two powers with different bases. I cannot do anything between them. I will just keep it as x squared y third. Well, again, you need to make sure in your final answer there's no negative exponent. If it happened like this, you are going to convert them into, by definition, the power positive exponent and flip it. Okay, now you can pause my video and try practice number 1 and number 2. Here, more exponent properties. And these are like more complicated ones. A power of a product is the product of the powers. Okay, so when you are multiplying a and b, right, you are really doing the a to the m and b to the m. Similarly, when you have a power of a quotient, you can take the quotient of the two powers. Okay, so you sort of give the exponent to each part of the factors of numerator and denominator. I don't want to call it a distributive, but you are giving it to each part. Okay, it's sort of like the sort of the routine is a little bit similar to the distributive law, that you have to give the outer thing to each part of the inner one, but this is not the distributive law that we have, because it has a particular meaning. Anyway, keep going. The next one, the power of a power, you keep the base and you multiply the exponent. So here you multiply them. And finally, this is a trick. If you have a negative exponent and the denominator, the base is a fraction, you can just sort of take the reciprocal in the base part. So you can just flip the base and meanwhile drop that negative sign. The reason is when you do 1 over A over B, it just gets flipped. That's how you sort of handle the make the exponent positive and put it on denominator. So you sort of put it on the denominator and then flipped it. Okay, so anyway, the last part is that when you are having a negative exponent, you can make it positive and then flip the base. No matter the base is a whole number or a fraction, you flip it. You take its reciprocal, you drop that negative sign. You can do that. And of course, then you can apply what you just see in the previous property. Then you can give that outer exponent to each of the inner part. In particular, if it's a quotient, then power of quotient is the quotient of powers. So those are like the rules when you have a exponent outside the parentheses, and inside the parentheses you have product, you have power, you have quotient, you have powers, and you might have a mixture of all of them. What do? Okay, so for example, let's see example 2. When you have 3x squared here, well, it's 2x squared times 3x squared. And the difference is without the parentheses, this is 2 times x squared. With the parentheses, this is 2x together squared, right? I hope at this moment you all know that. So 2x squared, there's nothing you can do, but 3x in parentheses, you need to do that. So this is a product. 3 times x is a product. With an outer exponent, what you do is you are going to place this exponent to each part of the factors. This will be 3 squared, x squared. Okay, so write it here. It will be 2x squared times 3 squared, x squared, where I will work out 3 squared, which is 3 times 3, 9, x squared. Then we go back to the multiplying in two terms. They're both positive, so number times number. 2 and 9 gives me 18, and x squared times x squared, I'm adding the 2. I'm adding the 2s, okay? It's 2 plus 2, that gives me x to the 4th power, not 2 times 2. Okay, so the answer is 18x to the 4th power. Next example, I'm having the third power of negative 2, x to the 3rd power. So same thing here, I am going to give this 3 to the number. You can't give the 3 to the sign, right? Sign itself doesn't make sense. So you give it to the number negative 2, then you give it to the sort of the power x squared. So what will happen is, if the factor, which are negative 2 and x squared, if the factor inside didn't have an exponent, like this negative 2, also like my 3 and x in the previous question, the outer exponent will just be the new exponent. So I will just place a 3 here, okay? I mean this 3, it will be like this way, right? But if the original factor x squared already has an exponent, what you are going to do is that you are going to keep the base, you are going to multiply the exponent. So you grab the 3, you want to give it to the 2. You give it by multiplication. This is 2 times 3. Okay, you multiply the outer exponent and the inner exponent together. Then negative 2 to the 3rd power is negative 2 times negative 2 times negative 2. You repeat 3 times, 3 times. So I'm multiplying 3 negative signs. I can cancel any 2 of them, and the third one will remain. Then I have 2 times 2 times 2, which is 8. So this is negative 8, and 2 times 3 for the exponent, of course, equals 6. So the answer is negative 8x to the 6th power. Here's the answer. Notice again, this means negative 8 as a number times the 6th power of x. Only x is in the exponent 6. Negative 8 are not. More examples. Here I'm involving negative exponents, or I'm mixing all the negative exponents in my questions. Question 3, I'm having 2s squared t negative 4 over 6 s negative 2 t negative 4. So first of all, when you are doing quotient, especially when you are doing quotient involving negative exponents, write it down. The quotient of powers, you keep the base, you subtract the exponents, right? So the new exponent will be the exponent from the top minus the exponent from the bottom. So pretty much the question lay out like the parts for you. This is the coefficient part, 2 over 6. Then you have s2 over s negative 2, that's your s part. And then you have the t negative 4 over t negative 4 part. And for 2 over 6, well, that's 2 over 6. We're going to reduce it later. For s, you are doing the exponent on top, which is 2, minus exponent on bottom. This is top minus bottom. Okay? The exponent from the top minus the exponent from bottom. And as you can see, when there are so many negative signs involved, it's very often that, I don't know, this negative sign or this negative sign get, it's very often students sort of mix them together, treat them as one. And of course, that would give you the wrong answer because you are supposed to keep change, and that gives you 4. Now for the t part, this is the exponent of s. The exponent of t, I'm having negative 4 minus negative 4. I keep negative 4. I change subtraction into addition. I change the second negative sign to positive. I'm actually having negative 4 plus 4, and that is 0. So 0. Now look at these 3 things we got. 2, 6. We need to reduce it. 2 and 6 share a 2. So I divide by 2. I have 1 over 3. S4 remains the same. T to the 0th power, anything to 0th power is 1. And when you multiply by 1, it just gets absorbed in multiplication. So you don't have to say anything about it. It will just be 1/3 s to the 4th power. Also, I want to point out, just like you can reduce 2 from the top and the bottom because 2 is a common factor, if you notice that t negative 4 and t negative 4, they are factors of the numerator and denominator, and they are the same. You can simply just cross them out because they are the same factors of the top and bottom, and that will be the same result, right? Because then you don't need to do the negative 4 minus negative 4, which give you 0, so you won't have the t to 0th power, which is 1, finally turn invisible. Okay, you could have just cancelled the t negative 4 from the very beginning. So this is one of the ways to do it, but there's another way of doing these kind of questions, which sometimes students find better. So let me give you the question back. So, or I have the 2s2 t negative 4 over 6 s negative 2 t negative 4. What you can do with your negative powers inside a fraction is that you can just grab the power and pull it to the other side. When it goes to the other side, it becomes positive. So let's move this one first. This will be 2s squared over 6s negative 2 t negative 4. And the t negative 4 from the top go down and become t positive 4. Okay, so when it comes down, it becomes positive 4. You drop that negative sign. Similarly, you can pull out the two powers of s and t, which are negative. This will be 2s squared, another s squared, another t4 over 6. These two things in the circle is already upstairs, t4. So, well, at some point again, you can cancel them. You're having 2 over 6. S squared times s squared. You keep the same base. You add the exponents. 2 plus 2 equals 4. And then you reduce. You will have the same answer. But in this way, you don't need to deal with the subtraction of signed numbers if you move things around. When you move these negative powers around, just be careful with the coefficients. Again, coefficient is not part of your power, so especially when you are moving the s negative 2, you can't move 6 s negative 2 upstairs. 6 does not belong to the power, hence when you change the sign, it doesn't affect 6. 6 remains where it was. Next question, I'm having a negative power of quotient of 2 negative powers. So it's a mixture of all negative powers. What you can do is I'll show you the move terms around way. So first, I will make it positive and then flip the base. When you make the power positive, you flip the whole thing. So this will be b negative 5. That's a 5 over 2a negative 3. Here I'm flipping the fraction. That's why 2 and a negative 3 goes together. Squared. Then I'm going to move the powers to the other side. The negative powers. This will be 2 remains on the bottom. A negative 3 goes to the top, becomes a third. B negative 5 goes to the bottom, becomes b fifths squared. Now I'm going to give this 2 to the 3, to the 2, and to the 5. And when you already had an exponent, like for a, the third and the outer second multiply together, the 3 and 2 give you 6. And if you didn't have an exponent like the 2, the outer exponent will just sit there. For b, it had a 5, so 5 times 2 give you 10. And then, well, I guess the only thing I need to do is 2 squares to 4, and that's it. That's the answer. Okay. Now you can pause the video and do practice number 3 and number 4. Finally, we go back to the scientific notation one more time. Here, what I want you to feel is 10 is like the axis. They are there. Yes, you can do their squares, you do their powers, but we don't want to touch it. We want it to remain as 10 with certain powers. It's just like the 2x to the 5th power. You don't want to do anything about x fifth, right? You want x there, you want the 5th there. Don't touch it. So the 10 in our scientific notation is sort of the axis, although yes, you can really do some calculations, say 4 times 10 give you 40, but you don't want to do it because you want it to be separated. If you view it that way, then you pretty much are having coefficient and 10 as the power, as the sort of the letter, okay, squared. So this is sort of my 4x squared and 5x negative 6. Okay. Then how are you going to do it? You multiply the number with the number. That gives you 20, and then you multiply the power with the power. You add the exponent, 2 plus negative 6. That is negative 4. Goes here. Now we go back to what we did last class. When we multiply powers of tens, we don't really do the multiplication. We just move the decimal point around. So for 20, which has the decimal point at the end, I'm multiplying by a negative power of 10. I am moving the decimal point to the smaller side, which will be the left. So I move it 4 times. 1, 2, 3, 4. And I am going to fill in all these zeros. So the answer will be 0.002. You don't have to write the last zero because that's insignificant, which means, at the end, which means at the right end of your decimal part, or actually on the left end, like the beginning of your whole number part. If there are zeros, you can drop them, except you need a number, a digit to represent the whole number part. I understand, 0.002 is acceptable, but that's not really the formal way of writing numbers. We do need the zero to occupy the whole number part to say, since you have the decimal point, the formal way is 0.002. Although if you write 0.002, I'm fine. Okay, next question, division. So I'm having the number divided by number 4/5 times the power divided by the power. I keep the base. I subtract the exponents, top minus the bottom. I keep change. That's 8. So I'm getting 4/5 to the times 10 to the 8th power. Now, the question asks me to write the answer in a decimal form, but I'm having a fraction. What do? You turn a fraction into decimal, okay, not a mixed number anymore, by same procedure. Numerator goes inside, denominator goes outside, but this time 5 doesn't go into 4. You are going to add the decimal point and the 0. So 5 go to 48 times. To get the 0, you need a 0 remainder, okay? Then you move the decimal point directly upward. So my 4/5 is actually 0.8 times 10 to the 8th power, and that will be 0.8, moving the decimal point 1, 2, 3, 4, 5, 6, 7, 8. It goes here. I need all these zeros. I'm having 1, 2, 3, 4, 5, 6, 7. So I'm having 8 with 0 sevens. That is 80 million. Last example, I'm having sign and sign, negative or positive, negative. 8 divided by 2, 4, times 10 to exponent on top minus exponent on bottom. So I keep negative 2. I change subtraction into addition. I change negative 4 to positive 4. That will be negative 2 plus 4, which is 2 squared. Then, for sign is still the sign. You are moving the decimal point of the absolute value part. So you keep the sign there. 4 is actually 4.0, right? Or 4 point. And you are making it bigger by multiplying a positive power of 10. So the decimal point goes this way, goes here, becomes negative 400. So sign has nothing to do with the change of the absolute value. Okay, so when you move the decimal point left or right, just bring down your sign. Keep the sign the same way and deal with the number, the absolute value. Okay, now you can finish practice number 5 and 6.